Welcome to lecture 54, Advanced Topics in Object Oriented Programming. So, in this lecture, I will start with HTTP and REST basics. All right. So, we know Hypertext Transfer Protocol, right? HTTP. So, usually you use in the browser, right? So, whenever you want to go to some website, most of you would have used this. So, this is a stateless protocol for transferring data over the web. For example, if you want to download or if you want to upload, right, or you want to see certain information, all right. So, that means that the data is being transferred. So, it is transferred through the web. So, there are certain commands or certain common methods like a get, post, put and delete. So, we will see. So, the next one is a representational state transfer, right? We call it as REST. This is nothing but architectural style for designing networked applications, right? So, this uses standard HTTP methods for CRUD. So, that stands for create, read, update and delete operations, all right. So, we will see, suppose we use, let us say, get slash user slash 1. So, this will retrieve user details, right. So, get command or get method will retrieve user details, and another one is the post slash users, right. So, this will add a new user, right. So, this is the basics of this HTTP and the best. So, we will see with an example in Python, right. So, we are going to see with the help of sockets for, right, or using sockets for HTTP communication. So, let us import socket, all right. So, let us import socket and the host here is www. some website example.com, right. So, you can change whatever the website that you want to put, you can do that. So, this is the host name and or you call it as a domain name, host name or a domain name, right. So, where we are connecting to. Port is equal to 80, line number 4, port is equal to 80. So, this is specifying the port number, right. So, this is specifying the port number. So, port 80 is the standard port for HTTP traffic, right. Port 80, it is nothing but the standard port for HTTP traffic. So, next line you have client is equal to the socket is invoking socket of. So, we know AF-INET is for IPv4, right, and the sock underscore stream, this is specifying the TCP protocol for reliable connection oriented communication, right. So, this we have already seen, right. So, one is for IPv4 and another one is the TCP protocol for reliable connection oriented communication. So, next line you have client which is invoking connect, right, by passing host and port, right. So, this is establishing a connection to the server, right. So, this is establishing a connection to the server at the specified host, right. For example, here we have www.example.com, right, and port 80. So, host is www.example.com, this is your passing and the port is 80. So, this is up to line number 7 and line number 9 you have request is equal to, right. So, you are having some statements get slash http slash 1.1 then backslash r and backslash nhost, right. So, then there you are having certain command, we will see, and then with this dot, okay, the format is invoking host, right. The format is being invoked where host is being passed, right. Format is being invoked, host is being passed. So, now if you look at line number 9, so you have get, right, get slash http, right. The meaning is it prepares an HTTP get request to retrieve the root resource, right. You are having slash, right. So, this slash, right. So, slash of web server, right. So, HTTP get, right, request, right, HTTP get request to retrieve the root resource slash, right. So, this is a slash of the web server. So, now you have get slash, right. So, this asks the server to retrieve the root resource and then you have HTTP slash 1.1, right. So, this is specifying the HTTP version being used, that means 1.1, right, is the most common. 1.1 is the most common. So, that you are using, right, 1.1, and then you have host, right. So, host with this host colon this one, I am considering this one, right. So, this required in HTTP/1.1 to specify the domain name of the server, right. So, in this case you have what, www.example.com, right. So, www.example.com, and then you have sequence of /r/n. So, this is nothing but the carriage return and new line. /r is for carriage return, here also you are using, right, and /n is for the new line, right. So, which are required to format the HTTP request properly, right. So, here you have /r/n/r/n. So, which is nothing but the end of the HTTP request headers, right. So, this is all about your line number 9. Next, what is happening? The client is invoking send, you are passing request and encode, right. You are passing request and encode, right. So, this is sending the HTTP request to the server, right. So, this is sending HTTP request to the server, request.encode. So, this you are passing, the request is invoking encode function. So, this is converting the string into bytes, right. So, this is converting string into bytes. So, this is required for sending over a socket. So, up to line number 10 is over. Now, go to line number 12. So, line number 12, client is invoking the received with 4096. So, what is the meaning? So, this is nothing but it is receiving the server's response, right, receives the server response. So, 4096, which is specifying the maximum number of bytes, right, the maximum number of bytes to read from the server at once, right, to read from the server at once. So, 4096 bytes, right, it is receiving the server's response, and the number 4096, it is specifying the maximum number of bytes, max number of bytes, right, to read from the server at once. So, up to line number 12 now we have completed. Now, if you go to line number 13, the print statement, right. So, here you have the print, right, which is a function, response is invoking decode, right. So, that means it is decoding the received bytes into a string, right, and prints the server's response to the console, right. So, the response dot decode. So, where it is invoking. So, this is decoding the received bytes, right, decoding the received bytes. So, that is converting into a string, right, and prints the server's response to the console, right. So, the response will typically be the HTTP status line, right. So, which is nothing but HTTP/1.1 and then 200 OK, right. So, something like that will be printed, right. So, that is a status line in fact. So, that is nothing but a status line, and the response headers, right. The response is nothing but HTTP status line 1 and the second one is response headers. So, response headers are nothing but content length or even both, right. So, next one is the actual HTML content of the web page, right. So, the third one is the actual HTML content of the web page. So, what I suggest here, you take some other example, right, in the www.example.com, instead of that you take some website, all right, and then you can try this. So, finally, you have client close. So, that means, so this is closes the socket connection to the server, right, freeing up the resources. So, now when you run the code, you will get the output like this, all right. So, this is some dummy www.example.com. So, that is why it is not been projected, right, purposefully I have projected. So, what you can do, what I suggest, you take some website, all right, and see the code, right, understand, and when you run it, you will get the output like this. So, maybe if you run the code, so let us say in the Python we will run the code, you will understand. Yeah. So, in the Python, so let us say Python 3, so you can see that, right. So, some example domain, all right, and then we are getting, this is the sample output that I put. So, what I suggest, you take some website, all right. So, consider some website as the input, all right. So, you are writing, all right. So, what we have done, so we have considered the host, right, www.example.com. So, in a similar way, you consider some other website, and so you can see the complete output like this. Okay. So, I hope it is clear now. So, next one is the networking libraries in Python. So, these are all the key libraries. So, when I am talking about socket, so it is low level, you have application programming interface API. So, it is a low level API for creating network applications. Socket is a low level API, and it supports TCP, the transmission control protocol, as well as user datagram protocol, right, and raw sockets. All right. So, this supports TCP, UDP and raw sockets. So, this is one of the key libraries. The second library is a request. All right. So, here you have a high level library for making HTTP requests. All right. So, requests, you have the high level library for making HTTP requests, and it simplifies the methods like a get, post, etc. And another library is asynchronization one, you call it as a asyncio. So, for the asynchronous framework, so this we had seen in case of C++ and Java, right. So, we can use this library, right, for this particular framework, the asynchronous framework, right, when you are using the network programming. So, you have the library called asyncio, and it is supporting concurrent input output operations, right. So, when you have the concurrent input output operations, so we can use the asyncio function, or you call it as a library. So, now what is the difference between the TCP and UDP, right? Just now we talked in the case of Python library, right. So, when you have to use both of them, right. So, as we had seen, TCP is nothing but the transmission control protocol, right. It is nothing but the connection oriented protocol. So, ensuring you have a reliable data delivery, right. So, you are getting a reliable data. So, either you are sending or receiving, right. So, your data should be the reliable one. So, the TCP is nothing but the connection oriented protocol, and this TCP uses acknowledgement and retransmission for error correction, all right, and for web browsing like HTTP, HTTPS, emails, right, SMTP server or IMAP server, file transfer, right, you call it as a FTP. All right. So, these are all the suitable applications for TCP. So, whenever, right, you are doing a web browsing, means it is based on the transmission control protocol, and even sending an email or receiving an email, right, SMTP server, you might have heard SMTP server, IMAP server, right. So, the email servers, TCP, and similarly file transfer protocol, FTP, all right. So, these are all coming under transmission control protocol. The next one is user datagram protocol, right, video streaming. So, nowadays this is very popular, right, or online gaming, right. So, many of you play online gaming. So, that is based on the user datagram protocol, right. Similarly, DNS lookups, right. So, this is the connectionless protocol where it is very fast and less reliable data delivery, right. So, compared to the TCP, so this is less reliable data delivery, right. So, nowadays we are very popular with all the online meetings, right. So, we need a video streaming. Suppose you want to present something, we need a video streaming. So, that means UDP has to come into your mind, right. So, that means with the help of user datagram protocol, so we can do the online meetings, you can share your videos, right. Similarly, online gaming, very popular, another one, it is based on the UDP, the user datagram protocol, right. So, these are all some of the cases or applications where you use TCP, right. Web browsing, email or file transfer, we use TCP, whereas the online gaming or video streaming we use UDP, right. So, this is the difference between TCP and UDP. So, one is the connection oriented protocol, and it is ensuring the reliable data delivery. So, whereas another one is connectionless protocol with faster, but less reliable data delivery, right. So, there is a difference between TCP and UDP. So, next what we can do, we will see how you can send and receive data with Python sockets, right. So, import socket. So, this we have done, and the next line number 4, you have the socket which is invoking by passing AF underscore INET. So, this is, we know this is for IPv4, and the sock underscore stream, this also we had seen. So, this is specifying the TCP protocol for reliable connection oriented communication, just now we had seen, right. So, these two are for that, right. So, the next line, the server underscore socket, which is invoking the bind function, right. So, this we had seen in C++ and Java, if you recall, you are passing local host and some number, let us say 1 2 3 4 5, right. So, the local host nothing but the server will listen for connections on the local machine, right, that is the meaning local host, right. The server will listen for connections on the local host or on the local machine, right. 1 2 3 4 5 you have a number, right, this is the port number, right. So, this is the port number on which the server will accept connections, the server will accept connections. And in the next line, server underscore socket, which is invoking listen and you are passing 1, right. So, this is preparing the socket to accept incoming connection requests, right, incoming connection request. So, 1 you are specifying the maximum number of pending connections in the queue, right, you are specifying 1 here, we are specifying 1 here. So, the meaning of 1 is, right, we are specifying the maximum number of pending connections in the queue, right. So, up to line number 8 we completed. So, the next line, line number 10 you have print, right, server is listening, right. So, this is printing a message, right, indicating that the server is ready and waiting for client connections, right. So, that is the meaning. And then you have, right, the connection comma address, that is equal to server socket is invoking the accept function, right. So, here you have the connection and address CONN, right. So, mainly the full meaning of this line number 12, which is nothing but this is waiting for an incoming client connection, and the CONN is for a new socket object, right. CONN is the new socket object for communicating with the connected client. And then you have address ADDR, so which is nothing but address IP and port, all right. So, this is IP and port of the connected client, all right. So, then the server will block until a client connects, all right. So, block means it is pausing the execution, correct. So, that is the meaning of the line number 12, and then you have a print statement. So, it is printing the address of the client that connected to the server. Line number 13 prints, right, address of the client that connected to the server. So, the object CONN, which is invoking send all, right, you are passing, we have that hello client, right. So, the meaning is it is sending a message to the connected client, right, it is sending the message to the connected client. Here you have B and then you have double quote hello client, right. So, that is what you are having over here. So, this is the message which is encoded as bytes before being sent, right. So, this is encoded as bytes before being sent. And then next line you have the object CONN, which is invoking receive by passing, you are passing 1024, right. So, this is receiving data from the client, right. So, this is receiving data from the client, right. So, 1024, which is nothing but the maximum number of bytes to read at a time, right, 1024 the maximum number of bytes to read at a time, all right. So, now the function blocks, right. So, this is pausing the execution until the data is received, right, it is pausing the execution until the data is received. So, line number 17 done. So, now you have print statement, right. So, received data is invoking decode. So, the meaning is it is decoding the received bytes into a string, right, exactly we had seen before, right, received bytes into a string and prints the message received from the client, prints the message received from the client, all right. So, then connection is invoking close. Once you execute this particular program, we are going to get the output like this, server is listening, connected by right. So, now some numbers we are getting and then you are having received hello server. Okay. So, what we can do, we will run the code using Python, right. So, let us see, we will go to the Python. Now, we are activating server, we are in activating server slide. So, here I will run Python 3, right. So, let us see, now you can see we have got the first line as the output, right, server is listening, right. So, now we have activated server. So, next we are going to see, right, activating client. So, once we activate client and then run the code, the next two lines will be printed, right. So, that what we can do, I will continue with activating client. So, then we will see the output. So, let it be there as it is, all right. So, now what we will do, we will go to the next slide and we will see how you are going to activate the client. So, let us see when you activate client. So, this is the code. So, import socket, rest of them are same, this also we had seen, and the client socket, local host and 1 2 3 4 5, this also you know that, alright. So, we have explained several times, and line number 10, right. So, the client socket is invoking receive 1024. So, we have already seen this line is nothing but receiving a data from the server, right. So, we know that the 1024, which is the maximum number of bytes to read at a time, right. So, now the function blocks until data is received or the server closes the connection. So, the next line you have print server, right. So, data is invoking decode. So, that means the decodes, it is nothing but decodes the received bytes into a string and prints the server's message, and it is printing the server's message. So, now you have the client socket which is invoking send all, right. So, here you have hello server, right. So, it is in the printed code. So, that means it is sending a response message to the server, right. It is sending a response to the server. So, the message, this particular message is encoded as bytes before being sent, right, and then send all. So, this is ensuring that all bytes to the message are sent, right. So, then you have the client socket which is calling the close, alright. So, when we run the code, so we will go to the Python because there is a connection between part 1 and part 2. So, we will see, right. So, we will run the code. So, here we are getting server hello client, and now you can see the previous program, right. So, you can see the output, right. So, maybe we can run one more time Python 3, right. In fact, we are seeing the output here, but for the confirmation we server is listening. So, we will run this one again. Once you are running and it is server is saying hello client, and then here you can see, right, the connected by 127.001, and then you are having the number, right, IP and port, and then it is saying received hello server, right. So, previously when we run, we have got only the first line server is listening, right, and dot dot dot, right. So, these things what you can do, you can try, right. So, these are the two outputs we had seen, and we are able to print those two output. So, whatever we have done, right, the previous script, that is you call it as a Python socket script. So, the server client we have done, right. So, we have created a TCP socket and binds it to the local host 1 2 3 4 5. So, that is what we have done in line number 7, and it is listening for incoming client connections, right. So, here you have the listen of 1, all right. So, all these I explained, all right. So, for your reference I have put as a text. So, the server script that is accepting a connection and exchanging the data, in fact, it is sending the message hello client, right. So, those things we had seen, first output we had seen, and then it is closing the connection after the exchange. So, in fact, it is receiving and prints the client's response. So, when you go to the client script, because only one line we had seen as output, all right. So, once we have run the client script, right. So, in fact, in the case of a client script, it is creating a TCP socket and connects to the server at the local host, right, some number, and it is receiving the server's message and prints it, right, and it is sending a response hello server, and it is closing the connection after sending the response. So, in fact, we have tested both, and we look at the server console and client console, we have got the said output, right. So, this output we had seen in both the consoles, server consoles as well as the client consoles. I hope it is clear now. So, now we have the concept broadcasting. What do you mean by broadcasting and multicasting in networking, right. So, broadcasting. So, when it is sending data to all devices in a network, right. So, assume that you want to send, let us say, particular message or email, right. So, to all the devices in the network. For example, you have address resolution protocol requests, right, ARP requests, you call it as address resolution protocol requests, right. So, the broadcasting which is using the broadcast address, some address. So, for example, here 192.168.1.255, right. So, this is using the broadcast address. ARP request is an example, address resolution protocol. So, this is broadcasting, that means you are sending the information or a data to all the devices in a network. A multicasting, what do you mean by multicasting? So, sending a data to a group of devices, right, you are sending to the group of devices. For example, video conferencing, right. So, video conferencing nowadays after COVID we are very familiar with this video conferencing, right, so many meetings, so many conferences, online conferences, right. So, that is an example of a multicasting. So, this is using the multicast addresses like the one you are seeing over here 224.0.0.0/4, right. So, this is a multicast address, this is an example of a multicast address. So, now here I have written a snippet, right, import socket, and the socket is invoking socket of, right, AF underscore INET. So, that you know it is a IPv4 addressing, and the socket datagram, right. So, this is indicating this is a UDP, right, this is a UDP datagram socket, this is a UDP datagram socket, and the next one IP porto underscore UDP, which is nothing but the UDP protocol will be used, right. So, this is specifying the UDP protocol will be used. And the next line SOC is invoking sets, right, SOC option, right, set SOC option, and socket dot IP porto underscore IP and socket dot IP multicast underscore TTL and then 2. So, what is the meaning of this IP porto underscore IP, right. So, which is specifying that the option applies to the IP level, specifying the option applies to the IP level, right. So, next one is IP underscore multicast underscore TTL. So, this is setting time to live, right, TTL stands for time to live, time to live, right. So, TTL stands for time to live for multicast packet, right. So, this TTL which is controlling the number of hops a packet can travel before it is discarded, right. So, the packet can travel before it is discarded, and setting it to 2, you are seeing 2. So, that is allowing the packet to travel across up to 2 routers, right, the packet to travel across up to 2 routers. So, that is the meaning of this particular line. So, now this SOC is invoking send to, you have multicast message and you have port and number, right, that means IP address and the port, right, IP address and the port. So, here you have multicast message, the data to be sent encoded as bytes, right, and 224.001 is a reserved multicast IP address, right, the reserved multicast IP address. So, this IP address belong to the range 224.0.0.0 to 239.255.255.255, right. So, starting from 224.0.0.0 to this, right. So, which is reserved for multicast communication, and 5000, right, the destination port number. So, this is nothing but destination port number, right. So, this is a snippet of Python. So, the next concept, asynchronous networking in Java, right. So, again NIO, right. So, we are coming back again to Java. So, NIO stands for new input output, right? NIO stands for new input output. So, we will see two code. So, that is why I put part 1 here. So, let us see. So, we are importing Java IO exception byte buffer channels dot star. So, these are all NIO dot byte buffer new input output, IO you know input output, here N stands for new, and third line you have Java Neo channels dot star, right. So, you have a public class which is a driver class NIO server, and here you have the main program starts throws IO exception. So, now line number 7 you have an object selector under selector, right. So, which is invoking open, right. So, here you are seeing selector, right. So, which is selector this one small s, right. So, which is a multiplexing mechanism. So, this is allowing a single thread to monitor multiple channels for events like read or accept, right. So, for read or accept this is a multiplexing selector is the multiplexing mechanism. So, line number 8 you have server socket under server socket channel because you have a new input output. So, you have all these classes and under this you have an object server socket, right. So, which is again invoking the open, right, which is line number 8, and line number 9 you have the bind method, right. So, the bind method which you are passing the inet socket address, right. So, the socket address is 1 2 3 4 5 line number 9, and 10 you have server socket which is invoking configure block false, right. So, here you have line number 9 inet socket address which is 1 2 3 4 5, right. So, the server socket channel, right. So, under server socket channel, so which is being created, right, which is being created, that means server socket object is being created and it is bound to port 1 2 3 4 5, that is the meaning, right, and it is bound to port 1 2 3 4 5, and then you have one more, right, server socket which is invoking configure blocking false, right. So, which is nothing but the non blocking mode which is enabling with server socket which is invoking configure blocking false, right. So, up to line number 10 we have done, and then line number 11 you have the register, right, that method by passing selector selection key dot op underscore accept, right. So, the meaning is the op underscore accept event, right. So, this is an event which is indicating that the server is ready to accept new connections, right. The server is ready to accept new connections. So, selector already we know, all right, this object we already we know. So, when it is invoking a register method where the class is, all right, in fact, the server socket, the object server socket, when it is invoking the register method, you are passing selector and the selection key dot op underscore accept. So, this is nothing but an event, all right. So, this is indicating that the server is ready to accept new connections, okay. So, up to 11, up to line number 11 we have done. So, line number 13 you have system dot out dot println server is listening, that means this is a simple print statement. So, which is indicating that the server has been initialized and is ready to handle client requests, okay. So, now while true selector dot select, so this method selector dot select, selector is invoking select. So, that means this method blocks until at least one of the registered channels is ready for input output operations. For example, you have accept, read or write, right, accept, read, write, correct. So, I am repeating again. So, when it is invoking the selector which is invoking select, right. So, this method blocks until at least one of the registered channels is ready for input output operations. For example, accept, read, write, right. So, the next one you have selected keys, right, the selector dot selected keys, it is a range for loop. The selector is invoking selected keys, that means this is returning the set of selection keys representing the channels that are ready, representing the channels that are ready. So, it will be assigned to key, right. So, that range for loop we know. You have now if statement, if key is invoking is acceptable, that means if it is true, that is it is checking if a new client connection is ready to be accepted, right? Then you have following statements, right? Otherwise, I will explain about that, what are all the statements. Otherwise, I will explain these 4 lines. So, if key is invoking is readable, right? What is the meaning of this? It is checking if a connected client has data to be read, right? It is checking key dot is readable, key is invoking is readable. So, it is checking if the connected client has data to be read. So, now suppose that key is invoking is acceptable, assume that if this is true, right. So, then you can see that you have an object client under socket channel, right. On the right hand side the server socket is invoking accept, right. So, the meaning is it accepts a new client connection, right. It is accepting the new client connection, and in line number 19 you have client is invoking configure blocking by passing false, right. The meaning is this configures the client socket channel to non blocking mode, right. The meaning is, so this is configuring the client socket channel to non blocking mode, and then again line number 20 client is invoking register, we are passing selector selection key dot op underscore read, right. The meaning is, so this is registering, right. We are at line number 20. So, this is registering the client channel with the selector for read operations, and then you have system.out.println client connected, right. If is acceptable is true, suppose key is invoking is readable is true, right. Line number 17 is false, obviously it will go to the else part, right. And here you have a client object under socket channel. So, key is invoking channel and buffer is an object under byte buffer. So, byte buffer which is allocating the maximum 256 bytes for incoming data, right. And then you have client is invoking read by passing buffer, right. So, that means it is reading a data from the client channel into the buffer, right. That is the meaning, reading data from the client channel into the buffer, and then you have system.out.println. So, here you have a received, right, the string which is invoking, right, the string. So, buffer is invoking array and then you have trim, correct. So, that means string buffer dot array and then trim, that means prints the, it is nothing but it is printing the received data into the console, right. So, you can look what are the trim function is doing, buffer dot array is doing, right. So, that means it is going to print the received data into the console, right. And then the selected key which is invoking clear under selector, right. So, when I run the code I have to get this particular output, right. Server is listening. So, let us see whether it is waiting for the client or not. So, we will see the output. We will run the code in Java. So, I am running this code. Yes, server is listening. Yeah, this happens like what we had seen in Python or in C++, right. So, now what we will do, we will see the part 2. Part 2 means the client one, right. So, what is the output we are getting? So, here you see server is listening, right. The server is listening output we are getting. So, to get the other output, so we are going to see, right. So, this we had seen server is listening, we are getting the output. So, let us wait, we have to run the other part. So, then things will work, right. So, this I will start. So, now the server is alive, right. In the previous code server is alive. So, now we will check the client part, all right. So, as usual, so IO, NIO, .NET everything is there, right. This is you are importing. Here you have NIO client, class is NIO client. So, this is the driver class for this program. You have main and here we are trying, right. So, here the socket channel, right, which is invoking open. So, here you have the inet socket address, the local host and the number, right. So, this is creating the socket channel, right. So, this line number 10 which is creating a socket channel and connects it to the server listening on port 1, 2, 3, 4, 5 of the local host, that is the meaning, right. I am repeating again. So, this particular line number 10 which is creating a socket channel and connects it to the server listening on port 1, 2, 3, 4, 5 of the local host. Okay. So, line number 11 you have client which is invoking configure blocking and then you are passing false. So, the meaning is it configures this particular command, this particular syntax configures the channel to non-blocking mode, all right. So, then you have the print statement. So, that means it is connecting to the server and then you have a message under string which is hello NIO server. So, this is not very difficult. Line number 17 you have object buffer under the class byte buffer. So, this byte buffer, that means the buffer is invoking wrap, you are passing message, you are passing message dot get bytes, that means the message is invoking get bytes. So, that means it creates a byte buffer to hold the message bytes, right. It is creating a byte buffer, it is creating a byte buffer to hold the message bytes, right. So, that is the meaning. And then line number 18 we have the client which is invoking write method by passing buffer, that means it is writing the message to the server, it is writing the message to the server. So, now system.out.println message sent, correct. So, whatever be the message, right. So, that will be printed. So, here we have an object read buffer line number 21 under the class byte buffer, right. So, here this read buffer, right. So, you have the allocate the same similar one we had seen previously. So, that means it is allocating a byte buffer with a capacity of 256 bytes to store the incoming data, right. So, this is what the meaning, the maximum 256 bytes, right, to store the incoming data. So, now while true these 4 lines will be executed, that we will see. So, you have bytes read which is a integer variable, right. So, the client which is invoking read function by passing read buffer, right. So, it is reading the data from the server channel into the read buffer, right. So, this is reading data from the server channel into the read buffer. If bytes read which is greater than 0, which is positive, right. So, it is checking if data was read successfully or not. The meaning here is, I mean, it is checking whether the data was read successfully or not. So, line number 25 we have the print statement, right. You have a print statement. So, receive new string of read buffer dot array 0 byte reads and trim, that means it is printing the received data to the console, right. It is printing the received data to the console, that is the meaning, right. So, we have already seen that read buffer dot array, right, and the trim, all right. So, then you have the client will be closed if there is any exception, right. So, that will be caught over here, all right. Otherwise, if there is no exception, if I run the code, I have to get the output, right. So, in the case of the client. So, let us see. So, that means it is connected to the server, the previous program, right, what we have not fixed, that will be run, right. So, now practically we will see. So, we will run the Java code. So, client I am running, right. So, once it is established, so we are seeing, all right, here you go, all right. So, here we are seeing the output in the server. So, that means it is connected to the server. So, both I have opened and you can see client, yes, connected to the server, message send hello NIO server, and here also we can see the output. Initially we have only server is listening, then client connected, and here you can see received hello NIO server, right. So, this is how we can establish the connection between the server and the client. So, this is with the help of Java. So, we are getting this output. So, we have seen in both client and server, in fact, this output also we had seen. This is with the help of Java. So, these are all some of the examples of the network applications, right. So, you have a chat application. So, nowadays everyone is using, right, one of the applications. A chat application is an example of a network applications. File transfer applications, either you have to download or upload, right, or with the help of a FTP you are transferring the file. Video streaming under UDP, right, the first two are under TCP, right. So, this is under UDP, and IoT applications, right. So, when you want to communicate between two IoT devices, right. So, we say these are all under the network application, and these are all some of the challenges we face in network programming. Concurrency. So, managing multiple clients efficiently, that is a challenge. Reducing delays in data transmission, many times it happens, right. So, when you are having a video chat, so the data transmission, right, if server side or the other side you have some problem, then there will be a delay, right, in the data transmission. So, this is another challenge. Error handling, more importantly handling connection failures and data corruption, right, which is a challenging task. And security, preventing data breaches and ensuring the encryption, right, ensuring the encryption. So, these are all the challenges we face in network programming, right. And in the network programming, we know that it is enabling the communication between systems over a network. So, you can have 2 or 3 or more, all right. So, it will be connected, all right. So, for that you require the network programming that we have studied, and then we talked about TCP versus UDP, right. One is the reliable versus the fast transmission. We talked about sockets, right. We talked about secured communication with the SSL and TLS, right. So, these are all the key topics we learnt, and the real time communication using WebSocket. We had seen several programs, right. So, on the practical applications point of view, so what you can do when you are trying to, right. So, once you are going towards network programming, so we can, right, or you yourself can write the program for the chat systems, file sharing and streaming, etc., right. So, these are all the what do you mean by network programming, what are all the key topics that you have to study in network programming, and what are all the applications, right. So, with this I am concluding this particular lecture. Thank you very much.